Welcome learners. This is Dr. T. Gangaram, lecturer in statistics, SVI Government College, Srikalahasti. The objective of this video lecture is to introduce you the exponential distribution, its definition, derivation of distribution function, and the four important characteristics: mean, variance, coefficient of skewness, and coefficient of kurtosis, and its MGF and CF. The definition: a continuous random variable x is said to have an exponential distribution with the parameter lambda greater than or equal to 0 if its probability density function is given by f of x lambda is equal to lambda e power minus lambda x for all positive values and it is 0 otherwise. Lambda is often called the rate parameter and it is widely used to model the time between independent events occurring at a constant average rate, that is radioactive decay inter-arrival timings. It is very important continuous distribution with respect to time. Derivation of distribution function of exponential distribution. The cumulative distribution function CDF or f of x is defined as capital F of x is equal to probability of capital X less than or equal to x for x greater than 0. F of x is equal to integral. The range is greater than 0, 0 to x up to x only f of t dt. This is equal to 0 to x. Instead of f of t, we can use lambda e power minus lambda t dt. Applying the power rule for integration, integral e power at is equal to 1 by a e power at. Since f of x is equal to lambda comes out using this rule, lambda comes out e power minus lambda t by minus lambda. Lambda gets cancelled, minus 1 remains. This is the upper limit x and this is the lower limit 0. Now f of x can be simplified as minus into e power minus lambda x minus e power 0, that is equal to 1. Taking minus into the bracket, it becomes 1 minus e power minus lambda x. So the distribution function of exponential distribution is 1 minus e power minus lambda x. Let us derive the moment generating function of exponential distribution. By the definition of moment generating function, mxt is given by expectation of e power tx for t less than lambda. It is mxt is equal to the range of exponential distribution is 0 to infinity e power tx. This is our e power tx into f of x dx. F of x is lambda e power minus lambda x. Combining the exponents power terms, e power, we commoning x here, minus lambda, minus of minus plus t into x dx. Lambda comes out and applying the rule we applied before, integral e power at is equal to 1 by a e power at. Here instead of at minus lambda minus t. Instead of a we have minus lambda minus a. Lambda already comes out e power minus lambda minus tx by minus lambda minus t over the range 0 to infinity. At the upper limit, lambda e power minus infinity becomes 0 for all positive values of t, and at lower limit 0, e power 0 is equal to 1. Now we substitute instead of e power minus lambda 0, instead of e power 0, 1 in this expression. mxt is equal to lambda here, maximum upper limit 0 minus minimum limit e power 0 is equal to 1 in the numerator, denominator minus lambda minus t as it is. This is equal to lambda by this minus gets cancelled and lambda minus t remains. Hence, the moment generating function of exponential distribution is lambda by lambda minus t. Using the expression of MGF expansion, mxt is equal to, we know that e power tx, the expansion of e power x, 1 plus t by lambda plus t square by lambda square plus t cube by lambda cube, so on. The mean is expectation of x is equal to m dash x 0, differentiating mxt is equal to lambda by lambda t. If we differentiate this expression once and keeping t is equal to 0, expectation of x is equal to lambda by lambda minus t whole square. In place of t, we need to keep 0. So lambda by lambda square, 1 lambda gets cancelled. 1 by lambda is the mean of exponential distribution. Similarly, for calculating variance of x is equal to expectation of x square minus expectation of x whole square. If we differentiate this expression twice, that is lambda double dash x, and keeping t is equal to 0, we get 2 lambda by lambda minus t whole power 3. At t is equal to 0, t becomes 0. 2 lambda by lambda cube, 1 lambda gets cancelled and 2 by lambda square remains. Applying the expectation of x square and expectation of x in the formula of variance of x, we get variance of x is equal to 2 by lambda square minus 1 by lambda square, that is equal to 2 minus 1, 1 by lambda square. It is the variance of exponential distribution. Let us derive skewness coefficient and kurtosis coefficient. Using the central moments derived from MGF, we calculate mu3 first for the calculation of gamma 1 and mu2 for the calculation of skewness coefficient. Skewness, by the definition of skewness, it measures asymmetry. Skewness is lack of symmetry. That is equal to gamma 1 is equal to mu3 by lambda cube. Mu3 is 2 by lambda power 3 divided by 1 by lambda square power 3 by 2. 2 gets cancelled and the lambda cube get cancelled and 2 remains. So the coefficient of skewness is equal to 2. The distribution is positively skewed. Kurtosis is, it measures the peakedness of the frequency curve. It measures tailedness. By definition of beta 2, coefficient of kurtosis is given by mu4 by sigma power 4. Actually, its definition is mu4 by mu2 square. mu2 square is nothing but sigma power 4. This is equal to 9 by lambda power 4 by 1 by lambda square to square. This becomes lambda power 4. Lambda power 4 gets cancelled and the numerator 9 remains. It is greater than 3. Gamma 2 is greater than 3, that is 6. So the distribution is always, exponential distribution is always leptokurtic and it is a positively skewed distribution. The characteristic function, by definition of characteristic function, phi of xt is given by expectation of e power itx. We derive it. The range is 0 to infinity. F of x is lambda e power minus lambda x dx. Similar to moment generating function, I adds here. Lambda comes out by combining the powers of exponents e power minus lambda minus it into x dx. Integrating with respect to x, lambda comes out e power minus lambda minus it into x divided by the coefficient term minus lambda minus it remains over the range 0 to infinity. By substituting the upper limit, lambda, the first term becomes 0, and from the second term it is 0, so the numerator becomes 1, and lambda remains here. Lambda remains lambda by lambda minus it. Minus lambda gets cancelled, and lambda by lambda minus it, this is also given by 1 minus it by lambda whole power minus 1. Thank you.